Hello everyone. Today I present how to secure Open SSH on Linux, one of the most widely used secure remote access protocols. I discuss the Open SSH implementation, its default risk, and three critical hardening techniques supported by both security frameworks and current research. This presentation integrates recent academic work such as Boehmer's, which exposed weaknesses in SSH sequence handling, and Felicius, who explored key extraction risk. Together, these studies remind us that SSH must be configured and maintained carefully to remain secure. I'll begin by explaining how SSH works and what vulnerabilities typically occur. Then move step by step through three hardening areas: authentication, encryption, and runtime monitoring. Finally, I'll show how to verify the configuration with tools like Nmap and Log Review. SSH runs by default on port 22, which is among the most scanned ports on the internet. As Terrari notes, attackers constantly use brute force or exploit outdated configurations. In 2024, Boehmers and colleagues published Terrapin Attack, demonstrating how subtle manipulation of SSH sequence numbers could bypass some integrity checks, especially in older or unpatched servers. Similarly, smart hacks illustrated that if a server's memory is compromised, poorly handled session keys might be extracted with ML techniques. These studies reinforce that SSH security depends not only on encryption, but also on strict implementation and maintenance. Before hardening, confirm Open SSH is running. Install with the package manager and check its status. Verify the service listed on port 22 using SS or NetStat. Then, from a remote host, run an Nmap scan to confirm port 22/TCP is open. This ensures your baseline configuration works before you lock it down. The first and most effective control is moving from password to key-based authentication. Keys like ED25519 offer strong cryptography and faster performance. And \etc /SSH /SSHD underscore config disable passwords entirely and enable only public key authentication. Also, this allows root logins. According to security guides from Linux Audit and Shadow Surface, these steps eliminate 99% of brute force attempts. Given SmartCat's findings about key leakage, it's also vital to protect private keys with paraphrases and restrict file permissions. The second hardening layer is encryption. SSH protocol 1 is deprecated because it lacks proper message authentication. SAT protocol 2 only. Restrict cipher and MAC algorithms to CTR and SHA-TAG2 families. This ensures resistance to known plaintext and downgrade attack. After the Terrapin paper, Open SSH patch is channeled sequence logic. So staying updated is crucial. Hardening configurations are only effective if your binary is patched. Hardening isn't only about crypto. It's also about runtime control. Set client alive intervals so idle session close automatically. Restrict SSH access to authorized users and groups only. Review /var/log/off.log for repeated failures or unknown keys. Georgia Tech University security guidelines emphasize correlating SSH logins with user behavior to catch compromised accounts early. After implementing changes, verify them and map confirm the service is running. Connection tests prove configuration integrity. A failed password login shows your server enforces key authentication. Review logs validate the hardening decisions and show compliance and traceability. The Terrapin attack proved that even mature cryptographic protocols can fail if sequence validation is weak. This reinforces the need for constant patching. Meanwhile, smart cats use machine learning models to retrieve keys from memory snapshots, reminding us to harden not only transmission but storage. These key real-world findings validate why Open SSH must be continuously updated and audited. To conclude, SSH remains the backbone of remote administration, but it's only secure when configured properly and maintained continuously. Enforce key authentication, modern ciphers, and tight monitoring. And as recent research like Terrapin and SmartCat shows, ongoing vigilance is just as important as good configuration. These references take peer-reviewed research with operational security sources. The 2024 and 2022 RCIV papers supply the theoretical foundation, while the Linux audit, Volter, and Shadow Surface guides offer implementation specifics for modern Open SSH deployments. This combination grounds configuration in both academic research and current best practice. Thank you.